back again with one more set of video. This time I have chosen such a topic which you have already understood from the introduction part, that is linear inequalities or inequalities, whatever it is. This is a topic which is common both for class 10 as well as class 11. Now, I hope the previous topics whichever I have uploaded, they were quite useful for you and you have been practicing sums as I had directed or as I had told you. Now, the students of class 12 are, I suppose, busy with their forthcoming examinations and I hope they are doing well. Now the time is for class 11 examinations as well as class 10 examinations, so I thought of taking such a topic which will be helpful for both the classes. So that is linear inequalities. Before that, I would once again like to remind you that please don't forget to subscribe my channel if you are new to this channel, so that whenever I upload any new video, and to remind you that always click on the notification bell so that if there is any new video you get it at once and you don't miss any video. And I hope that you will enjoy the video, but you have to see to the last so that the concept becomes very clear and distinct to you. So without wasting much of our time, let us begin. Now we have already studied about equations. Equations means there will be something equation equal to sign and some variable and equal to 0 or some other number maybe. Then from here easily we could find out the value of x, that is minus 3. So this is what equation is. This is known as linear equations because the power of x is 1. Now what we are going to deal in this video is linear inequations in one variable. Linear inequations in one variable means either we have less than sign or greater than sign or less than equal to sign or greater than equal to sign. This type of symbols will be there and with variables and constants. We are supposed to find out the values of x or the range of x for which a given inequation is satisfied, just like x plus 3 as I had taken less than 2. So we have to find out the values of x. Now x can be an integer, x can be a whole number, x can be a real number, x can be a rational number. That very much depends on how x is defined. So we are supposed to find out the values of x and by transposing or simplifying or whatever it is. Now we should know certain rules of inequations before I proceed with the solution of the problems. First of all, let us take an example. Suppose we know that 5 is less than 7. I hope there is no doubt in that. 5 is less than 7. Now, if I change the sign on both sides, then minus 5 and minus 7 it becomes. We know in a number line, as we go towards the left hand side, the numbers keep on decreasing. So if here it is 0, here it is minus 5, then this side will be minus 7. That means obviously minus 7 is far left side of minus 5. So that means what? Minus 5 is greater than minus 7. Or else, let us take another example. Say minus 3 is less than 6. Very true fact that negative number is always less than a positive number. That means if I change the sign on both sides, that means minus 3 I make it plus 3 and 6 I make it minus 6. Then obviously minus 6 is less than 3 or 3 is more than greater than minus 6. So what is the conclusion from these two examples? That is, if A is less than B, then minus A is greater than minus B. Is it okay? This is one rule. Second rule is, suppose we take an example, say 2 less than 3. 2 is number less than 3. Now if I take the reciprocal on both sides, that means half. Reciprocal of 2 means 2 by 1 is, reciprocal is 1 by 2. And this side reciprocal of 3 is 1 by 3. So 1 by 2 and 1 by 3, if I compare the fractions according to the rule of fraction, obviously 1 by 2 will be more than 1 by 3. So when we change the fractions on both sides by doing the reciprocal on both sides, then the fraction symbol also changes. So if A is less than B, then 1 by A is greater than 1 by B. If I remember these two rules, I suppose we shall not have any confusion or problems in solving the initial problems which are there in class 10 related to linear inequalities. Now let us take one or two examples to understand how to solve a given linear inequations to find out its solution set. So let us see this example of inequation, how to solve this inequation or what are the values of x. Now before that, I would like to tell two more terms before solving this inequation. That is, one is known as the replacement set. Replacement set. Another one is the solution set. So what is the replacement set? Now when this inequation is given, suppose this inequation is given, along with that it is always given that what is x? X can be given that x is a natural number, or x is just an integer, or x is a whole number, or x is a real number. So here suppose it is given x belongs to set of real numbers, x belongs to R. Here R is a larger set from where I have to get the values of x for this particular inequation. Means x is real number. So this larger set is known as the replacement set. Now from the replacement set, I have to get only those values of x which will satisfy this inequation. So those values of x are known as the set of solutions or for the value of x, or that is known as solution set. I think it is clear that what is replacement set? Replacement set is a bigger set where the variable x is defined, and solution set is the number of values or the set of values of x which satisfies this particular inequation or whatever inequation is given to us. Now, whenever you get any inequation, what are the steps that you should usually maintain? First of all, you try to simplify both the sides. Here, it is very simple example. I should deal with some more difficult problems also. First of all, you should simplify both the either side of the inequation, and then bring all the variables on one side and all the constants on the other side. If there is any fraction part, take LCM and remove the fraction, or the decimal part, remove the decimal, and bring all the x terms together on one side, right, maybe on the left side or on the right side, and on the constants on the other side, and then make the coefficient of x as 1. These are the three steps you should follow. First of all, you should simplify left side, right side, transpose here and there, and get all the variables one side, means terms containing x, and all the constants one side. And then remove the fractional parts and make the coefficient of x 1. Now here it is a simple example. Let us see how to solve. So here it is, all the x are already on one side. So let us take the LCM, that is 6. So 6x plus 3x plus 2x is less than 11. So 6 plus 3, 9 plus 2, 11x by 6 is less than 11. I told I have to remove the fractional part. So I multiply by 6 on both sides. I get 11x less than 11 into 6. Then I told that I have to make the coefficient of x 1. That means I divide both sides by 11. So x is less than 6. So finally we have achieved that x should be less than 6. So what are the numbers less than 6? It can be 5.9, 5.8, 5.7, 5, 4, 3, 2, 1, 0 and many more. Because R is an infinite set. R is a set of real number. So what is the solution set? Solution set. Solution set is all those values of x such that x is less than 6, x belongs to R. Or else we can write this one as, this is known as strictly less than, because it is strictly less than, no equal to sign is there. So 6 is not included because less than, not less than equal to. So 6, and this side, the left side, lesser values of 6 will be up to minus infinity. So minus infinity to 6 is the range of values of x. This is the solution of this particular inequation. We shall see some difficult example or difficult inequality to solve. Please wait. Let us focus on this particular inequation. It is a bit tougher than the previous example which I took. This is, first one is 5x minus 7 is less than 3x plus 3. This question has two inequations separately given. 1 minus 3x by 2 greater than equal to x minus 4. Now we have to find out those values of x which satisfy both the equations. So let us see the first one. So this side we have 5x minus 7 is less than 3x plus 9. We will transpose all the variables on one side. So 5x minus 3x is less than 9 plus 7, or 2x is less than 16, or x is less than 8. Okay, now this side we transpose all the x first of all this side. So minus x minus 3x by 2 is greater than equal to minus 1 minus 4. Taking LCM, 2 minus 2x minus 3x is greater than equal to minus 5, or minus 5x is greater than equal to minus 10. Now we have minus both sides, as I had told you in the beginning itself, that if I change the sign on both sides, then the sign of the inequality also changes its direction. So 5x is less than equal to 10, or x is less than equal to 2. So we have first this one, second this one. So let us take the number line and understand the solution. So x, suppose here it is 8. Values of x should be less than 8. That means this side. Suppose here I take 2. And here it is 8. 8 is not included. Then values of x should be less than 2. Less than equal to 2. In both cases, either the values of x should be, if I combine both the cases, the values of x should be less than 2, values of x should be less than 8. So combining both the cases, if I take this portion, this satisfies both the inequations. Means if I take here, say suppose here it is 1. 1 is less than 8 as well as 1 is less than 2. So the solution set is x such that x is less than equal to 2, x belongs to real number. To tell you one thing which I forgot to tell, that is, if nothing is given about the replacement set, then we shall take the replacement set to be the set of real numbers. So we can write in interval form, that is minus infinity to 2. 2 is included, so it is in closed bracket, and this is not included, so that is an open bracket. So this is the solution set or the range of the values of x. Let us see the next question. In this example, we have yet two inequations. If I separate them and write, we have, say, minus 2 by 3 less than minus x by 3 plus 1 is one inequation. Another one is minus x by 3 plus 1 less than equal to 2 by 3. Now let us take this part first. So minus 2 by 3 minus 1 is less than minus x by 3. 3 is LCM, minus 2 minus 3. Minus 5 by 3 is less than minus x by 3, or minus 5 is less than minus x, or x is less than 5. On this part, we get minus x by 3 is less than equal to 2 by 3 minus 1, or minus x by 3 less than equal to 2 minus 3, or minus x by 3 is less than equal to minus 1 by 3, or minus x is less than equal to 1 minus 1, or x is greater than equal to 1. Combining both of them, we get the solution set as x such that x is less than 5 and more than equal to 1, x belongs to real number. Then if I graphically represent this solution on the number line, then what is the graph, or what is the number line looking like? So here we have 1, here we have 5, all the numbers in between them, but 1 is included and 5 is not included. In that case, we mark 1 and we darken it, which shows it is included, and here 5 we make a hollow circle or an empty circle, and in between we shade it. This is, we shade the whole thing because the replacement set was set of real numbers. Therefore, the solution set will also have real numbers. Now, let me add up with this question itself. Suppose instead of x equal to belonging to R, if the replacement set was x belongs to W, or x belongs to M, means natural numbers. So in that case, what are the solution, or what are the values of x? In between 1 to 5, what are the whole numbers, or what are the natural numbers? Because whole numbers begin from 0, natural numbers begin from 1. So 1, obviously 2, 3 and 4. Not 5, because 5, x is less than 5. It is not x less than equal to 5. If it would be less than equal to 5, then I would have taken 5 also. Now, how to represent this on number line? In this case, what we see is they have distinct values. They do not have infinite values. They have distinct 4 values when x belongs to natural numbers, or x belongs to whole numbers. Can be x belongs to whole numbers also, any one of them. So here what we do, we individually dot, give 4 dots and write 1, 2, 3, 4. This side, obviously this arrows should be given both sides, because number line means it is carried over both sides. And here you can write 0, here you can write 5. But this particular point should be darkened properly to show that they are the solution of that set. For this inequality, this is the solution when x belongs to n natural numbers, and this is the solution when x belongs to real numbers. Now, this was the concept which we have understood, the examples that we saw, which are related to class 10 syllabus. Now, in class 11, a bit more is there. That is the graphical representation of inequations. When two inequations are given, how to graphically represent them on the graph paper, how to find out the solution region or the shaded region where two inequations satisfy or one inequation satisfy. Let us see the 1 or 2 examples related to those. Now I shall take up the inequalities, solution of inequalities in graphical method. Previously what we were doing, that was algebraic method. After that we shall see when a system of inequations are given, how to solve them. Now suppose this inequation, x is less than equal to 2. Now considering x equal to 2, if I take x equal to 2, that is a line which is parallel to y-axis. Now let me tell you, when I draw this line, x is equal to 2, this line, then that line divides the whole plane into 2 halves. Left half, this is the left half and this is the right half. Now I have to shade those parts where it satisfies this particular equation. Now we have infinite number of points on this side, infinite number of points on this side of the half, left half, right half. Let us take some point, say on this side. We can take the point 3, 0. If I put here 3, 0, means x is 3, what we get? 3 is less than equal to 2. Now, is this inequality 3 less than equal to 2 a true statement or a false statement? Obviously, we will say it is a false. 3 cannot be less than 2. 3 is more than 2. In that case, this point does not lie in the solution region. So what happens? So the points which are on the other half or the left half are the points which satisfy this inequality. Let us take the point. Suppose we take the point 1, 0. Or we can take anything. We can take 0, 2 also. We cannot take 0, 2 because there is no y. Even if we take x, we will put 0. Anyway, if we take the point 1, 0, then we put 1 in place of x, 1. There is no y, so there is no case of putting the value of y. So 1 we get less than equal to 2. I suppose this is a correct statement. This is a true statement. Previous one was a false statement. So 1 is greater than, 1 is less than 2, less than equal to 2, less than or equal to. So the points on the left side of this line are the solution set. So we shade it this side. The left plane is the solution. Let us take this example. X less than equal to minus 1. So if I take x is equal to minus 1, then this is a line. X is equal to minus 1. Sorry, this is not the line. X is equal to minus 1 will be the line which is parallel to y-axis. This is the line, not this. Now if I put here 0, 0 is less than minus 1 is not a true statement. It is a false statement. So 0 is here. So we don't shade this side, we shade the other side. Let us take y equal to 3. That means y is equal to 3 is a line parallel to x-axis. This is y equal to 3 and this was x is equal to minus 1. Now if I put 0, 0 is greater than 3. Is it true or false? I suppose it is false. 0 cannot be more than 3. 0 is always less than 3. So I don't shade it towards 0. I shade it away from 0. So this side is the solution set. Suppose you have understood where to shade. Now let us come to this. When we have a set of two variables, when we have two variables x plus y less than equal to 5. Let us consider this as x plus y equal to 5. This is the equation of a straight line. Writing it in intercept form, x by 5 plus y by 5 equal to 1. So x intercept is 5, y intercept is also 5. Now if I draw the straight line, I get this. Now if I take a point, now this line divides into two halves, upper half, lower half, upper half, lower half. We have points in the upper half, many points. We have many points in the lower half. Let us take a point. Best point is 0, 0, the origin. If I put 0, 0 here, 0 plus 0 is less than equal to 5. 0 is less than equal to 5. Obviously 0 is less than equal to 5. There is no doubt in that. So this is a true statement. Thus, if it is true, we shade it towards the point which we had considered. I repeat, if it is a true statement, we shade it towards the point which we had taken. If it is false statement, we shade it away from that point. We shade it on the other half. If it is upper plane and lower plane, we shade it on the either on the upper plane or on the lower plane. If it is left plane or right plane, we shade it either on the left plane or on the right plane. This is how the shading is done. Now, problems will arise when we have two inequations or a system of inequations. Let us see one example related. Now here we have a system of inequations. 2x plus 3y less than 12, 3x greater than or equal to 2, y greater than or equal to 1. Let us take the first one. Here, mind it, it is less than, not less than equal to. So if I write it in equation form, we get 2x plus 3y is equal to 12. So it is equal to 12, or x by 6 plus y by 4 is equal to 1. X intercept is 6, y intercept is 4. This is first one. Second equation is x is equal to 2. This will be a line parallel to y axis, and y is equal to 1. This will be a line parallel to x axis. Let us draw the graph. This is 0, x axis. This is y axis. 1, 2, 3, 4, 5. This side we have 1, 2, 3, 4, 5 and 6. This side is minus 1, minus 2, rest again minus 1. Now 6 and 4, x intercept is 6 and y intercept is 4. Since it is less than, not less than equal to, we draw a dotted line. Please keep this in mind. If it is less than, then the points on the line are not included. If it is less than or more than. If it was less than equal to, then we would have drawn a straight line or a continuous line. Here we have given a dotted line. Second case, x is equal to 2. X is equal to 2 is a line parallel to y axis. Here it is a continuous line because less than, it is greater than equal to. Y is equal to 1. This is the line. Y is equal to 1. This is y equal to 1. This is x is equal to 2. And this line is x by 6 plus y by 4 equal to 1. Now the shading portion begins. First case, Let us take here. Suppose this is the point 0, 0, which is this line, dotted line, divides into two halves, upper half, lower half. So 0, 0 is in the lower half. If I put 0, 0 here, I'll get 0 plus 0 less than 12. Obviously 0 is less than 12 is a true statement. If it is true, I told we have to shade it towards the point which we have considered. Clear? Second, x is greater than 2. This is the line. If I take the point 0 again, if I put here 0 greater than 2 is a false statement. So we shade it away. We shade it away from the line. Is it okay? So this side we have to shade. Third one, if I put 0 here, 0 is greater than 1. This is again a false statement. 0 cannot be more than 1. So we shade it away from 0 on this line. Okay, all the three lines we have shaded. Now we have to find out that particular region which is satisfied by all the three inequations. So what we notice is this is the region where all the three lines overlap. Shading of all the three lines overlap, excluding the line x by 6 plus y by 4 equal to 1 because it is less than. So this is the solution region. All the points within this region are satisfied by this equation. So this is the graphical solution of a given system of linear inequations. I hope each and every problem that I have explained was well understood by you. If not, please don't forget to write in the comment box. If yes, always give a like and write whatever comments you have so that I may improve, or I will surely try to improve in my next videos. If you have more doubts, please give your demand in your comment box. I shall provide more and more problems for your sake. Thank you viewers. See you again. Keep studying. Keep well. God bless.